Hey guys, this is speed day 8, and you should have a packet in front of you titled Speed 3. I'm not going to make you rewrite all the formulas today because you should know those by now. Alright, let's get started. The distance between A and B is 3,400 meters. Lihua walks from A to B in 40 minutes and takes 5 minutes more to return to A. What is Lihua's average speed in meters per minute for the whole journey from A to B and back to A again? So you guys, for this problem, let's make sure we start off by drawing a model, because this could get really confusing. And let's just mark it, A and B. And I'm also going to just start my chart over here on the right with my distance 1, speed 1, time 1, distance 2. Actually, let's do this up and down today because it's just the space that I have. So distance 2, speed 2, and time 2. Okay, now let's mark up our word problem. So the distance between A and B is 3,400 meters. Okay, that's obviously my total distance. Lihua walks from A to B in 40 minutes. So she takes 40 minutes to get there and takes 5 minutes more to return to A. That more is key there, you guys. That doesn't mean that she takes 5 minutes to walk back, because that would basically be impossible. It means that she takes 5 minutes longer than she did before. So she's going to take 45 minutes on her way back, okay? So over here on my chart, let's fill in time 1, 40 minutes, and time 2, 45 minutes. And the distance 1 and the distance 2 is the same. It's 3,400 meters. So we'll fill that in for both. And we don't know the speeds, do we? I don't believe. Nope. We don't know the speeds right now. And we want to know the average speed for the whole trip. So we don't need the speed 1 and the speed 2. We just need total distance and total time. So let's find out total distance first. Distance total equals distance 1 plus distance 2. So 3,400 plus 3,400. So total distance is going to be 6,800 meters. Okay, now my total time I also need, and that's going to be 40 minutes. Oops, I should probably write my formula in there. It's time 1 plus time 2. And that's going to be 40 minutes plus 45 minutes. So my total time is going to be 85 minutes. All right, I think we're set. We have everything we need to find our average speed. So let's set that up. Average speed is going to be total distance over total time, which is going to be 6,800 meters over 85 minutes. And we're going to need to figure out what that is. So let's do that up here. We have 6,800, and you should be doing this on your own, by the way. I know you know how to do division. 85 won't go into 68, so I'll go over here to my hundreds. 85 will go into 680, and I'm going to guess it's going to go about 8 times. 8 times 5 is 40, and 8 times 8 is 64, plus 4 is 8. Oh, look at that. I was right. And we have a remainder of 0, but we still need to bring down that other 0. 85 goes into 0 0 times. So my answer is 80 meters per minute. Okay. Are you ready for another one? Let's go ahead and do number 2 together. An airplane flew from A to B in 3 hours, covering a distance of 540 kilometers per hour. On the return trip, as the weather was bad, the average speed was reduced by 60 kilometers per hour. How many hours did the airplane take to return from B to A? All right, let's start off with our chart over here. Distance 1, speed 1, and time 1. Distance 2, speed 2, and time 2. And so we're just setting everything up right now. Let's also draw a model for this word problem. We have A and we have B. The airplane flew there for 3 hours at 540 kilometers per hour. On the way back, it took longer because it was slower by 60 kilometers per hour. So to find that speed, we're going to do 540 minus 60, and the answer is going to be 480. So it flew back at 480 kilometers per hour. So that's going this direction. We don't quite know yet how much time that took. We don't know our distance one yet, but we do know our speed one. It's 540. And our time one is 3 hours. Our distance two we don't know. Our speed two is 480. And our time two we don't know yet. We have to figure it out. Well, our distance is from A to B, and from B back to A is going to be the same. So let's find that first. We can see that if we look over here, we can find that distance. So let's do that right now. Distance 1 equals speed 1 times time 1. So distance is going to equal 540 times 3. And that is going to be, let's do that over here in the corner, 540 times 3. 3 times 0 is 0, 3 times 4 is 12, and 3 times 5 is 15, plus 1 is 16. So 1,620, oops, I wrote miles, but that should be kilometers. 1,620 kilometers. Okay, let's go back and fill that in on our chart. And since the distance is the same both directions, we'll fill that in for both distance 1 and distance 2. And now we can figure out time 2, which is what we're trying to figure out, isn't it? So time 2 is going to be distance 2 divided by speed 2. So 1,620 divided by 480, 1,620 kilometers divided by 480 kilometers per hour. Let's cross off those kilometers, and let's cross off a 0 here. And let's do the math over here. So 162 divided by 48, and I'm going to guess it's going to go in there about 3 times. You know what? I'm going to rewrite this because I can see right off the bat I'm going to need to have some decimal places, and I'm not going to have enough room over there. So, all right, so you can see I've done my division over here, and I just went ahead and paused the video and did that because I knew it was going to be a little bit lengthy. But if you want to check to see how I got 3 37/100ths of an hour for time, there it is. I just went ahead and stopped at hundredths. I believe on your notes it says round to the nearest hundredths, and that's fine because it could go on for a little while. All right, let's do the next one together. And why don't you guys pause the video and give this one a try on your own if you're working at home, and then come back and check your answer. All right, well, I hope you started out by making a chart that looks like this, and possibly a model. That's what I'm doing. It says a sports car travels from point A at a speed of 84 kilometers per hour and reaches B in 1.5 hours. There's my speed one right there and my time one. A normal car travels at 2/3 of the sports car's speed. How many hours does the normal car take to reach B? Whoa. Well, let's start filling in our chart here really quick. We have a speed one, it's 84 kilometers per hour, and we have a time one, which is 1.5 hours. And we don't have a D1 yet, do we? Now, we don't have a D2, an S2, or a T2 right now. All right, well, we can, with the information that we have, find the distance from A to B. So I already have my formula written there. So D1 equals S1 times T1. Let's fill in some values. It's going to be 84 kilometers per hour times 1.5 hours. You know what I'm going to do? I'm going to actually, since we're working with fractions here, let's change that 1.5 to a mixed number. And the way I do that is I'm going to do 2 times 1 equals 2, and then I'm going to do plus 1, which equals 3. So that's 3/2. Okay, so D1 equals 84 kilometers. And I'm going to do 84 over 1 just to have a fraction there too, since I'm going to be multiplying it by 3/2 of an hour. Okay, and I can do some cross-canceling magic here. I can cross that off, or cross-cancel with the 84. 2 becomes 1, and 84 becomes 42, and my D1 equals 42 times 3. Let's do that over here. We'd like to do all our calculations over on the side of the page. So 3 times 2 is 6. 3 times 4 is 12. So 126 kilometers. I'm going to go ahead and mark that on my model here. And then let's write it over here in our chart. 126 kilometers. Okay, well, the distance from A to B is going to be the same for both cars. Okay, so it's 126 kilometers for D2 as well. Now, my question is, how many hours does the normal car take to reach B? And the speed that it gives me in my word problem, where it says a normal car travels at 2/3 of the sports car's speed. We're going to have to figure out what that is, aren't we? So let's do that. Let's find speed 2, because we can't figure out that time 2 until we figure out that speed 2. So speed 2 is going to be 2/3 of, and now remember that in math, of means multiply, of the sports car's speed, and the sports car is speed 1, so 2/3 of 84 kilometers per hour. Okay, so speed 2 is going to equal 168 over 3, and I multiplied 2 times 84 and 3 times 1 to get that. So let's see what that is. Let's divide that over here. 168 divided by 3. 3 goes into 16 5 times. And then 3 goes into 18 6 times. So my speed 2 is going to be 56 kilometers per hour. So we'll fill that in over here. Okay, now I think we're all set to find time. And you know what I'm going to do is I'm going to make my paper just a little bit neater by sectioning this up a little bit, okay? And then let's section off our calculator over here. So my time 2 I can find now because I've got my distance 2 and my speed 2. So time equals distance over speed, distance 2 over speed 2. Time 2 equals 126 kilometers over 56 kilometers per hour. And my time 2, you know what we could do is we could probably cross cancel this and divide both by 2 if we wanted to. 126 divided by 2 is going to be 63, and 56 divided by 2 is going to be 28. And now I'm going to have to do some math. We'll do that over here. We're going to divide 63 by 28, and we're definitely going to need a decimal place there. 2 times 28 is 56. Then we're going to subtract. 13 minus 6 is 7. 5 minus 5 is 0. Let's bring down that 0. 28 goes into 70 twice, and we get 56 again. 70 minus 56 is 14. We're going to bring down another 0. And 140 divided by 28 is going to be 5. 5 times 8 is 40. 5 times 2 is 10, plus 4 is 14. And I'm done. So my time 2 is going to equal 2.25 hours. So it will take the normal car 2¼ hours to reach point B. Okay, the rest of this video I'm going to continue in part 2, so go ahead and check that out next.